Hi guys, just a quick video here to show you the Adaptronic E1280s, and one thing I just wanted to show you in the software was an example of the advanced view, and it's a very simple example but just to show what it can do and show a sort of real life example of a function that was created or modified and why it was modified and the car that it was modified on and why we needed that. So I'll show you the software here. Bear with me, set this camera up. And we have a bit of focus there. So this is the Adaptronic Sakuku software. For the Sakuku stands for Adaptronic Super Engine Control Unit Configuration Utility. So what we have here is the base layout, which is the standard layout that you get in the Sakuku software. This map is the 1GFE Turbo, which is the map, and it's partially mapped, partially tuned for these Lexus IS200 Turbo. And the problem we have on this car is that it runs a electronic throttle from factory. Now the Adaptronic E1280, it will run electronic throttle, no problem at all. But in order to get this car up and running initially, we decided that we'll just use the excuse me, we'll use the cable throttle. So we've disconnected the drive-by-wire throttle and we're just going to use the cable throttle for now just to get the car running. Now this creates another problem, which is that there's no idle air control valve on this car, and there's not really any easy way to fit one because the inlet manifold is plastic, so there's no real simple way to fit an idle air control valve onto this engine. So on our cold start we don't have any increase in idle airflow in order to keep the engine running, and what happens is that on cold starts in the mornings the car idles very low, and if you give the throttle a quick rev, the car will then drop down and it won't be able to idle, and it can cut out and die sometimes. So when it's cold in the mornings it can be a bit of a pain. As soon as it starts heating up it's okay, but we'd like to see if we could counteract that in some way just to make the drivability a bit better for cold starts. So one way to do that, to try and keep the idle increased, is to use ignition timing, and we can increase the ignition timing when cold, which will tend to push up the RPM on the idle slightly. It doesn't work just as well as an actual idle valve will, but it does certainly help. So if I go to ignition outputs here, we have our main ignition map 2, which are both 3D tables, and we have an air temp correction, which is an ignition trim, which is a 3D table, and we also have a coolant correction, but in this case in the base layout it's a 2D table, which most of the time works perfectly well, and I'll show you the 2D table. What we have here is our ignition timing axis across the top, and we only have one axis. So it's coolant temperature, should I say. So that's 0 degrees coolant temperature up to 100 degrees coolant temperature, and you can then edit whatever your ignition timing wants to be, and so on. So at the minute it's all 0, so there's 0 trim being applied for coolant temperature. Now the way we would do this is when the ignition timing is below 50 degrees, for example, we could add in, again, for example, 10 degrees ignition timing. We could trim that out to 5 at 50 degrees and so on, and as the engine heats up then we want 0 degrees because it'll idle perfectly fine. The problem with this is that if we put 10 degrees ignition timing in here at 0 degrees coolant temp, then that applies 10 degrees across the board, no matter whether the car is at idle or on full boost. There will be a 10 degrees ignition advance applied when the coolant temperature is low enough. So we really don't want that. We only want to apply the ignition correction when the car is idling. So what we want to do is have a second axis down here, which relates to manifold pressure. It's probably the easiest way to do it. So that when it's at low manifold pressure and low coolant temp, we can, or you could have RPM there as well if you wanted. So at your idle RPM, it could push it up. But I'd say manifold pressure is probably the easiest one to do. So if we select our idle manifold pressure and put an increase in ignition timing, and then as the pressure increases, we can reduce the increase back to 0. So what we need to do is go into the advanced view, and this is the gem of this software, and this is why it works so well. Now it does take a bit of time to set up, but if we go into advanced view, we can then go and edit all these maps and make them. You can create brand new maps as well. So here we have the advanced view, and it's brought us back to page 1, which is gauges, and this shows you all the gauges, so you can edit what gauges you see and so on. So what we want to find again is ignition outputs, which will bring us back to our ignition page. And all these boxes here are all called elements, and basically the whole software is made up from elements, and all the elements are linked together in various different ways. They can be linked together on the same page, or you'll have here, for example, page 14, ignition retard degrees for idle, and so on, which is probably similar sort of items to what we want. So if we go, this is our coolant correction table, and you'll see it's a 2D table, and here's the air temp correction table above, which is a 3D table. So we basically want to change this to a 3D table so it is the same as the air temp correction. So in order to do that, we right click on that. Sorry, I'll have to unlock the configuration first. We right click, we'll delete that element, and there we have that element's gone. Now that element used to link down into this next element here, which is basically a sum. So this gets added on to this box, which gets added on to this box, and so on, which is a lot of different sums, and eventually that gives you your final ignition output with all trims taken into account. So if we right click here and we want a new element, and this time we want a 3D table. So, and we will call our 3D table ignition coolant correction. Okay, now here's where we set up the table. So the horizontal reference value will be the same horizontal reference value as we had before. So this will be our coolant temperature. So we want our coolant temperature from 0, which will be the lowest value, and the highest value, again, we're happy enough, we'll keep that at 100 degrees, that's more than enough. And we want our step size for that to be 10 degrees. That will give us a bit more resolution. This vertical value will be manifold pressure. So I know that this car idles at about 40 to 45 kPa of manifold pressure. So if I put in 30 here as our lowest value, that gives us plenty. And although we don't need it, but I will put it in just as an example to show, but that's about the highest kPa we really want to see on this car. We're only going to boost it about half a bar, so that's 150 kPa, which equates to about half a bar. We'll not need to edit anything up at that level, but I'm just putting it in there for an example anyway. And we want our step size. I would say step size will be 10 on that as well. It's like it was a fairly big map that we don't really need, but again, as an example, just to show, we'll go for that. So we have that element added. We'll just move it back up to where we want it. Get the page correct. So now we have input 1 and input 2, which is both our axes that we just talked about there, and we have various different outputs that we can take. So if we go to input 1 and just right click on that, we can edit the link, and what we want to have here as our input 1, as we said, is coolant temperature. So link to another element, and we will select the page that coolant temperature is going to be on, which is analog inputs, and we need to find ECT. This is analog input 12 ECT. That's the one we need. So that's going to link that from another page straight into this element. We want to do the same with our input 2. Edit link, and this time we want manifold pressure. Now you will notice here on the air temp correction that it doesn't have a raw manifold pressure. It has estimated map, which is a calculated map after the signal has been filtered and so on. So in order to keep everything right, we'll just stick with the same parameter. So we go to the map estimation page, and there we have estimated map, and there we go. That should pop up estimated map here. Yep. So we now should have our 3D table, but it's going nowhere. It's not linked to any output, and we want to link it back to this sum, so it gets added into the total sum for ignition timing altogether. So what we do is click on this link, right click, and we can edit link. Now we want to find the ignition outputs page, which is the page that we are on, and you should find in here ignition coolant correction, and there it is, ignition coolant correction, and we'll click that, and there we have our link straight from one element into the other. So whatever our output for this table is then gets added into the sum over here for all the ignition outputs, and then on to the final output. So what we want to do is lock that configuration. We'll come out of advanced view, and we will go back into the ignition outputs page, and now you'll see ignition coolant correction is a 3D table instead of a 2D table. So we click on that, and we now have a 3D table here. So for example, before, if we wanted, let's say if the car idles at 45 kPa, so we'll take up to 50 kPa. You could even go 60, it probably wouldn't make much difference. And you could add at 0 degrees, say 0 degrees coolant temp, let's put 15 degrees ignition timing in there. We want that to gradually filter out, so say up to about 60 degrees coolant temp. Sorry, move the camera there. We just right click that, interpolate rows, and there we have, when the car is cold and it's at idle kPa, it's going to have a 15 degree ignition increase, and it will gradually filter out back down to 0 by 60 degrees, which should be enough. It obviously needs tested, but it gives us the function to do that now, whereas we didn't have that function before. And you can also see that when we're at 100 kPa, which is atmospheric pressure, or even up to boost, we've got 0 ignition correction, 0 at all. So, and we can also, if you want, you can add, if you're on high boost, on high coolant temps, you can put, for example, -2 degrees in there. So if we're getting up to 100 degrees of coolant temp and we're on high load, then it's going to trim a couple of degrees out, which will keep the engine safe if it's getting too hot, if it's overheating. Again, you can play about with this all you like, but that's just an example of what can be done. It all should be tested and measured as best as possible. So thanks guys for watching, and I'll try and add this into the video of these Lexus IS200, and we'll get some dyno videos and everything else, the usual story. So just following on from the demonstration that I did with showing the Adaptronic advanced view in the E1280s software, we're sitting with the engine now. It's just idling here on cold start. Cooling temperature there is about 35 degrees at the minute. Our map there is about 47 kPa, and our RPM is quite low for a cold start idle. It's just 6.5, 7,000 RPM. This car idles about 1,000 RPM on, you know, when it's pretty warm. So what I want to do is just show you this trim here. So if I add in, say, 10 degrees here, and just watch the RPM. The RPM's now picked up almost 8,000 RPM there, just with that trim. So maybe add another 5. We'll go for 15 there then, and that's picked it up another bit again. So that seems to be a bit happier there, and I can then, you know, edit these next columns here. We'll maybe put 12 degrees in here, and we can go back, and obviously these want to interplay up. I wouldn't put too much more than 15 degrees in, because it has a diminishing effect the more ignition time you put in. But that seems to idle a lot happier. And what I'll do is, just to show you again, just to confirm, I'll drop these back to 0. Let me see. So we'll go for 0 and we hit enter, and again, watch in the bottom left hand corner, the idle RPM will drop. So we're back down to about just over 7,000 there, but which is an improvement, but that's because the car is warming up. So I'm happy enough. We'll go for 15 degrees here. That seemed to work reasonably well. Let's pick the idle up again, and the next 60 degrees, well, we'll actually go for 12. We'll actually go for about 10. And 70. You can go for 5. And then at 80 degrees back to 0. So once up to full operating temperature, which is above 80 degrees, we will have 0 trim. And these sights here for colder ignition timing, I'll just drop those or increase those to 20. And even if it's a little over advanced, it's not really gonna, I mean, for example, I'll put 20 in just to show, because it's only on idle, it's not on full load, so there isn't going to be any detrimental effect really. 20 degrees has picked it up again a bit there, so that even 20 degrees would be good enough for that. Our actual ignition timing is probably not just quite 20 degrees, but I mean that's good enough, and it does well enough to pick the idle up there. So yeah, just wanted to show you that. There's a lot that can be done with this software. It's a brilliant job. It works really well for custom setups, and you know, it's pretty much your imagination is the limit. So thanks for watching, and hopefully I'll speak to you guys soon.